8.2 right-angle trigonometry. With this right-angle trigonometry, we're working with trig functions, which means just sine, cosine, tangent, SOHCAHTOA. We've done this before in geometry, so this shouldn't be anything that's really, really new. So first thing that we want to look at is, what is sine? Sine is y over r. It's your length of your opposite side over the length of your hypotenuse. Remember, your hypotenuse of any right triangle is always the longest side length. It's the side length that's across from the right angle. So if we look at sine, we're dealing with our opposite over our hypotenuse. Cosine is x over r, which is the same thing as our adjacent over our hypotenuse, and then our tangent is y over x, which is just our opposite over our adjacent. So for our first example, we are given a right triangle with values for our three side lengths, and we are asked to find the sine, cosine, and tangent for the function for theta. Theta is just representing an angle measurement. So the first thing that I like to do is find where my theta is. From there, identify my opposite, my adjacent. My opposite is going to be the side length that's opposite of theta. So this is your opposite. Your adjacent is the one that's right next to. You don't ever want to do anything with that hypotenuse because it's always going to be the side length that's across from the right angle. So this 39 would be your hypotenuse. So your sine is opposite over hypotenuse, which in this case is going to be 15 over 39. You simplify that because they are both divisible by 3, and you are left with 5 over 13. Your cosine is adjacent over hypotenuse. So our adjacent is going to be the 36 over our hypotenuse, which is 39. These both are divisible by 3 once more, so this is 12 over 13. And your tangent is your opposite over adjacent. So this is going to be 15 over 36. 15 and 36 are both divisible by 3 once more. So this is 5 over 12. For our next example, we are given this right triangle with side lengths of 16, 30, and 34. The 34 is our hypotenuse because it's opposite of the right angle. Our theta is in that top corner, so our opposite is going to be the 30, and our adjacent is going to be the 16. So sine is opposite over hypotenuse, so opposite is 30 over hypotenuse, which is 34. These are both divisible by 2, so 15 over 17 is our sine. Cosine is adjacent over hypotenuse. So our adjacent is 16, our hypotenuse is 34. Once again, they're both divisible by 2, so this is 8 over 17. Our tangent is opposite over adjacent. So our opposite is 30, our adjacent is 16. Divide them both by 2, we have 15 over 8. So for our next part, we're finding side lengths of special right triangles. Remember your special right triangles from geometry. You have your 30, 60, 90 triangles and your 45, 45, 90 triangles. So with these, you can use sine, law of sines, you can use law of cosines. You need to remember that your sine for 30 degrees is 1, if like for this 30-degree angle with side lengths 1, 2, and the square root of 3. Again, this is all from geometry, so you should know this. For 30, 60, 90 triangles, your side length is going to be opposite of your 30 degrees. It's always going to be 1. Your smallest side length is 1. Your hypotenuse is always 2. Your middle side length is always the square root of 3. For your 45, 45, 90 triangles, your two side lengths that are the same are both 1s, and then your hypotenuse is the square root of 2. So if we look at example 3, you're using the trigonometric function to find the value of x. So this here is a 30, 60, 90 triangle. Use the side lengths for 30, 60, 90s. Your one that's across, that's your hypotenuse, is a 2. The one that's on the 60, that's your shortest, is the 1. And then the middle side length is that square root of 3. So you're setting up a proportion here, similar to working with law of sines, law of cosines, but again, you're working with these special right triangles, so we're using these side lengths to form our proportions. So if you are finding x, you are going to take the side length that we have, So that's the 60 degrees. You're using the 60 degrees. We are going to be working with opposite. This is adjacent. This is your hypotenuse. All right, so we are going to have opposite over hypotenuse for sine. We're working with sine here. So that's opposite over hypotenuse. We have x that we're finding. We have the 100. We want to work with those two side lengths. So this is the same thing as x over 100. If we use the side lengths for our special right triangles at 1, 2, square root 3, we are going to use the square root of 3 because it goes where the x is, and then the 2 because it goes where the 100 is. And we are going to solve our proportion using these two fractions. So from here, we can cross multiply. We're going to get 2x is equal to 100 square root 3. We divide each side by 2, and we get that x is equal to 50 square root 3. For our next example, we have a 45, 45, 90 triangle. So we're going to have side lengths of 1, 1, and square root 2. Your hypotenuse is always the square root of 2, and your two other side lengths are 1. So look at the values that you have. You have the 45. You're working opposite and hypotenuse. Opposite, hypotenuse. So that's with sine. Opposite over hypotenuse. Your opposite is x, your hypotenuse is 20. Now use the side lengths that we have for a 45, 45, 90 triangle. That's 1, 1, and the square root of 2. So 1 is in place of the x, and the square root of 2 is in the place of the 20. So from here, we use these two fractions and cross multiply. So we're going to have the square root of 2 times x is equal to 20 times 1, which is 20. We divide each side by the square root of 2, and we rationalize that denominator. So from here, we are going to multiply top and bottom by the square root of 2, so that way we can rationalize that denominator, and we get that x is equal to 20 square root 2 all over the square root of 4, which is 2. So then these can simplify, the 20 and the 2, which become 1 and 10. So x is equal to 10 square root 2. For example 5, we have a 30, 60, 90 triangle. The side opposite of that 30 degrees is x, and then we have the adjacent side length. So we are going to work with tangent, because tangent is opposite over adjacent. For a 30, 60, 90 triangle, we have side lengths of 1, 2, square root 3. Remember, your hypotenuse is always 2. Your side length that's smallest is 1, and that square root of 3 is that middle. So for opposite over adjacent, we're working with 1 and the square root of 3. We have x and 12. X is our opposite, 12 is our adjacent. Our 1 is also our opposite, and our square root of 3 is also our adjacent. So we are going to cross multiply with these. So 12 times 1 is 12, and then x times the square root of 3 is x square root of 3. We divide each side by the square root of 3. We rationalize that denominator, and we're going to have 12 square root 3 is equal to the square root of 9, which is 12 square root 3 over 3. The 3 and the 12 can simplify, becoming 1 and 4, so x is just 4 square root 3. From our next example, it tells us that a builder is constructing a wheelchair ramp from the ground to a deck with a height of 18 inches. That's here. The angle between the ground and the ramp must be 4.8 degrees. We have that too. To the nearest inch, what should the distance d be between the end of the ramp and the deck? So we're looking at this hypotenuse here. Or sorry, no. We're looking at d, which is our adjacent. So look at your angle. We're working with opposite and adjacent. So opposite and adjacent is tangent. So we are going to work with the tangent of 4.8 degrees is equal to opposite, which is 18, over our adjacent, which is D in this case. So we want to multiply each side by D to get it as a whole number, not a denominator. So this is going to leave us with D times the tangent of 4.8 is equal to 18. To get D by itself, we're going to divide each side by tangent, 4.8. And use our calculator. When we use our calculator, we are going to get 214 inches. For example 7, it tells us that a skateboard ramp will have a height of 12 inches, and the angle between the ramp and the ground will be 17 degrees. To the nearest inch, what will be the length L of the ramp? So we are working with opposite and hypotenuse. Opposite and hypotenuse is sine. So we are going to be taking the sine of 17 degrees is equal to our opposite, which is 12, over our hypotenuse, which is L. We're going to do the same thing we did with the last one. So multiply each side by L. Those cancel out. We're going to have L sine 17 is equal to 12. And then we divide each side by the sine 17 to get L is equal to 41 inches. Again, you'd have to use your calculator with this one to figure out that's equal to the 41 inches. For our next part, we're dealing with angles of depression and angles of elevation. So this again is from geometry. Angles of depression just mean that your angle is opening downwards. Angles of elevation just means you're working or going upwards. So with this, sometimes it's a lot easier to draw pictures. You'll realize in your completed notes I've drawn pictures for you with these examples, so that way it makes a little bit more sense. For example 8, it tells us that a park ranger whose eye level is 5 feet above the ground, which means from his eyes to the ground there's 5 feet. So if you want to draw yourself a little picture, do that. This is 5 feet. From here to here is 5 feet. All right, from there it tells us that the ground measures the angle of elevation to the top of an eruption of Old Faithful Geyser to be 34.6 degrees. All right, so from him, wherever he's standing, to the geyser is a distance. It's going to form an angle to the top of the eruption, which is going to be the 34.6 degrees. So this angle in here is 34.6 degrees. Okay. So, and then this really shouldn't be hit. Okay, hold on one second, because this has to change. So from where his eye level is up is the 34.6. Okay, so from here, it tells us that if the ranger is standing 200 feet from the geyser's base, so from here to here is 200 feet. What is the height of the eruption to the nearest foot? So the whole idea is to find the height of the eruption. So from here to here is just the eruption. The total is from the ground up. So our whole idea is to find from the ground up. So first we are going to find x, and then we're going to add x to the 5 feet. So looking at what we're finding, we have opposite, we have adjacent. Okay, so we're going to do opposite over adjacent, A for adjacent, there we go, which is tangent. So from here, we are going to take the tangent of 34.6 degrees and set it equal to the opposite, which is what we're finding, over the adjacent, which is 200. We're going to multiply each side by the 200 to get x by itself, and use our calculator to get 200 times tangent 34.6, When we plug this into our calculator and we round, we are going to get that x is equal to 138 feet. So if we add that to the 5, this is going to leave us with 143 feet for the eruption. For 9, it tells us that a surveyor whose eye level is 6 feet above ground, so we're going to draw the person again. From here up is 6 feet. So from there, we're going to either be going up or down. It tells us that for a surveyor whose eye level is 6 feet above ground measures the angle of elevation. So this is going to go up. So our triangle is going to be above where his eye level is. To the highest hill on a roller coaster to be 60.7 degrees. So this degree measurement is 60.7. If the surveyor is standing 120 feet, so this is here, from the roller coaster, so this is the top of the roller coaster. What is the height of the hill to the nearest foot? Okay, so, really not roller, it's a hill, I'm sorry. I'm looking at a picture and doing this at the same time or reading it and drawing your picture at the same time. So, we're looking for the total distance between the ground and the height of the hill. So this is going to be x plus this 6. So we are finding x. We are working with opposite and adjacent one more time. So opposite over adjacent is tangent. So tangent of 60.7 degrees is equal to opposite, which is x, over adjacent, which is 120. So we multiply each side by 120, and we get that x is equal to 120 tangent 60.7, which in our calculator, if we plug that in, we get that x is equal to 214. From here, we're going to add 6 to this to give us that total height, and we get 220 feet. Okay. So for our next part, we are dealing with reciprocal trigonometric functions. So reciprocal trigonometric functions are just cotangent, secant, and cosecant. Your cosecant is the opposite, reciprocal of sine. So instead of it being your y over r, you're going to do r over y, so it's going to be hypotenuse over opposite. Your secant is the reciprocal of cosine, so that's going to be your adjacent over hypotenuse is going to turn into hypotenuse over adjacent. And then your cotangent is the reciprocal of tangent, so instead of it being your opposite over adjacent, it's going to be your adjacent over your opposite. So for these, we're going to be finding the 6 trigonometric functions for theta. In example 10, we have side lengths of 14, 48, and our hypotenuse. Well, we don't know what our hypotenuse is, but we do know that it's our hypotenuse. So this here is your adjacent for 14. The opposite is the 48. So we have to find the hypotenuse. So use what you know. What do you know? A squared plus b squared is equal to c squared. So from here, we're using the Pythagorean theorem. We're going to have 14 squared plus 48 squared, squared is equal to c squared. All right, so for this, the 14 squared gives us 196. The 48 squared is 2304. We add these two, and it gives us 2500. Is equal to c squared. We take the square root of both sides, and we get that c is equal to 50. So this hypotenuse is 50. Now we can find the 6 trigonometric functions. So sine, cosine, and tangent. For sine, we're going to have opposite over hypotenuse, so that's 48 over 50. which is going to give us 24 over 25. For cosine, we have 14 over 50, so that simplified is 7 over 25. And then tangent is 48 over 14, which simplifies to be 24 over 7. For our cosecant, we're going to represent it as CSC, which is the reciprocal of 24 over 25, so 25 over 24. For cosine, the opposite, or the reciprocal of that is secant, so that's SEC, and that's going to be the reciprocal of 7 over 25, so 25 over 7. And then for tangent, our reciprocal is cotangent, so that's COT, which instead of it being 24 over 7 is 7 over 24. So we're looking at, this is our sine, our cosine is a 7 over 25, our tangent is a 24 over 7, our cosecant is the 25 over 24, our secant is the 25 over 7, and our cotangent is the 7 over 24. For example 11, we have side lengths of 18 and 80. We're missing again out that hypotenuse. So we're going to use the Pythagorean theorem. So a squared plus b squared is equal to c squared. So 18 squared plus 80 squared is equal to c squared. That 18 squared is 324. The 80 squared is 6,400. We're going to add those two to give us 6,724 is equal to c squared. We take the square root of both sides. We get that the square root of 6,724 is 82, and 82 is equal to c. So our hypotenuse is 82, our theta is here, our opposite is the 80, our adjacent is the 18, our hypotenuse is this 82. So sine is opposite over hypotenuse. That's going to be 80 over 82. We simplify that, and that gives us 40 over 41. Cosine is adjacent over hypotenuse, so that's 18 over 82. We simplify that again, we get 9 over 41. Oops. Okay, there we go, sorry, 41. And then for our tangent, we have opposite over adjacent, so that's 80 over 18, which is going to simplify to be 40 over 9. Our reciprocal of sine is cosecant, so CSC, reciprocal of 40 over 41 is 41 over 40. For the reciprocal of cosine, it's secant, so SEC. Instead of it being 9 over 41, we are going to have 41 over 9. And then instead of tangent, we're going to have cotangent. So take the reciprocal, that's 9 over 40. So we have sine, which is 40 over 41. Cosine is 9 over 41. Tangent is 40 over 9. Cosecant is 41 over 40. Secant is 41 over 9. And cotangent is 9 over 40. For 12, we have a triangle that's on a coordinate plane. So we have an ordered pair that's 5, 12. Remember, your 5 is your x value. That's so it's going side to side. So that x is 5. Oops. Move back to the pen. There we go. Our x is 5, and that y is the 12. So we still need to find that r, which is our hypotenuse. So in order to find r, use your Pythagorean theorem. So 5 squared plus 12 squared is equal to c squared. 5 squared is 25. 12 squared is 144. If we add these, we get 169 is equal to c squared. So take the square root of both sides. So c is 13. Remember, our sine is y over r. Our cosine is x over r. Our tangent is y over x. Our cosecant is going to be r over y. our secant is going to be r over x, and our cotangent is going to be x over y. So plug in these values. Y, we said was 12. R is 13. Cosine, x over r, x is 5. R is 13. Tangent, y over x, y is 12. X is 5. For cosecant, r over y, r is 13. Y is 12. Secant, r over x, r is 13. X is 5. Cotangent, x over y, x is 5. Y is 12. So sine is 12 over 13. Cosine is 5 over 13. Tangent is 12 over 5. Cosecant is 13 over 2. Secant is 13 over 5. Cotangent is 5 over 12. For example, 13, same thing. So we have side lengths of 6 and 5. We are missing our hypotenuse. So we're going to do 5 squared plus 6 squared is equal to c squared. 5 squared is 25. 6 squared is 36. We get c squared. We add these two. 25 plus 36 is going to give us 61 is equal to c squared. We take the square root of both sides. Can't take the square root of 61, so c is equal to the square root of 61. So again, find your sine, your cosine, and your tangent. From there, flip them, find the reciprocals. So sine is opposite over adjacent. Your theta is here, so opposite is 5, adjacent is 6. Your hypotenuse is the square root of 61. So sine is opposite over hypotenuse, so that's going to be 5 over the square root of 61. You cannot leave the square root of 61 in the denominator, so we are going to multiply the top and bottom by the square root of 61. And we are going to have 5 square root 61 all over 61. So sine is 5 square root 61 over 61. Cosine is going to be adjacent over hypotenuse, so 6 over the square root of 61. And again, you can't leave the square root of 61 in the denominator, so multiply the top and bottom by the square root of 61. This is going to give you 6 square root 61 all over 6. So your cosine is 6 square root 61 over 6. Your tangent is opposite over adjacent. Your opposite is 5. Your adjacent is 6. So that one you didn't have to go any further with. Now from here, find your reciprocals. The reciprocal of sine is cosecant, so CSC is equal to the hypotenuse, which is the square root of 61, over our opposite, which is 5. You don't have to do anything with that one, so that one is your answer. For your cosecant, the reciprocal of that is secant, so SEC is equal to the hypotenuse, which is the square root of 61, over your adjacent, which is 6. Again, we don't have to change anything with that one or rationalize the denominator. It is rational. Your reciprocal of tangent is cotangent. Oops. And that's your adjacent over hypotenuse, so 6 over 5. If we look at our next example, we have P that is 4, negative 5. It's on our terminal side of theta in standard position. We're finding the exact value of the 6 trigonometric functions for theta. We're going to treat this the same exact way that we were treating the ones that we just did before this, the 2 before. The only difference with this is we're going to turn that negative 5 into a positive 5 and then treat it the same. So again, your x is the 4. That's your side to side. Your y is your up and down. That's going to be 5. So we can redraw this triangle to be 4, 5, our right angle. We have to find our hypotenuse. So we are going to have 4 squared plus 5 squared is equal to c squared. We have 16 plus 25 is equal to c squared. So this is going to give us 41 is equal to c squared. Take the square root, and c is the square root of 41. So what is theta? Now, the only way to figure out what theta is to use this graph. Theta is your, okay, so a lot easier than this to figure out what theta is. Your x value in your ordered pair is x. Your y value in the ordered pair is y. Your r is the side length that you had to find, which is your hypotenuse. Use that with your sine, cosine, and tangent. So remember, sine is y over r, cosine is x over r, tangent is y over x. When you find cosecant, it's going to be r over y. When you find secant, it's going to be y over x. And when you find cotangent, it's going to be x over y. So to find all 6 of these, we're just plugging in values. So our x is 4, our y is 5, and our r is the square root of 41. So just plug these all in. So y, we said, is 5 over the square root of 41. We're going to multiply top and bottom by the square root of 41 to give us 5 square root of 41 over 41. Cosine, x over r. X is 4, r is the square root of 41. So again, multiply top and bottom by the square root of 41. So this is going to leave us with 4 square root 41 over 41. Tangent is y over x, so this is just 5 over 4. Now take the reciprocal of these. The reciprocal of sine is cosecant, so that is going to be the square root of 41 over 5. The reciprocal of cosine is secant, so instead of it being 4 over the square root of 41, it's going to be the square root of 41 over 4. And the reciprocal of tangent is cotangent, so instead of it being 5 over 4, it's 4 over 5. So we have sine is 5 square root 41 over 41. Cosine is 4 square root 41 over 41. Tangent is 5 over 4. Cosecant is the square root of 41 over 5. Secant is the square root of 41 over 4. And cotangent is 4 over 5. For our last one, we have P is negative 3, 6. So our x is going to be 3, our y is going to be 6. We have to find the 6 trigonometric functions for this. So first, find what r is. R is the same thing that you would find for c. So 3 squared plus 6 squared is going to be r squared. 3 squared is 9. The 6 squared is 36. If we add these, we get 45. So we are going to have 45 is equal to r squared. We take the square root of both sides. That 45 is going to be 5 and 9. The 9 is 3 and 3. So that r is going to be 3 square root 5. So then write down all of your things. Sine is y over r. Y over r. Cosine is x over r. And then tangent is y over x. Let's find these first. Sine is y over r. So it's 6 over 3 square root 5. The 3 is going to turn into a 1. The 6 turns into a 2. We then also have to rationalize that denominator and multiply the top and bottom by the square root of 5. So then this is going to give us 2 square root 5 over 5. For cosine, you have x over r, so that's 3 over 3 square root 5. So those 3's are going to simplify to be 1's. And then that square root of 5, you'll multiply the top and the bottom of that fraction by. So this is going to give us the square root of 5 over 5. For tangent, you have y over x, so that is 6 over 3, which then simplifies to just be 2. Your reciprocal of sine is cosecant, so that's r over y, which is going to give us the square root of, 3 square root 5 over 6. The 3 turns into a 1, the 6 turns into a 2, so that's just the square root of 5 over 2. Your reciprocal of cosine is secant, so that's r over x. R we said was 3 square root 5 over x, which is 3. The 3's cancel, so this is going to give us just the square root of 5. And then your reciprocal of tangent is cotangent, so that's x over y. So that's going to give us 3 over 6, which then simplifies to be 1 over 2. So our sine is 2 square root 5 over 5. Our cosine is square root 5 over 5. Our tangent is 2. Our cosecant is square root 5 over 2. Our secant is the square root of 5. And then our cotangent is 1/2.